Hi, in this video we're going to go through how to run a TensorFlow application on 6 different GPUs in parallel using hops. So the first thing you'll need to do if you do not have an account on hops.site is register. So you click on the register button, fill in your first name, last name, email, password. You'll also need to fill in a security question. Pick one like your mother's maiden name. Agree with the terms. But unless you know what you're doing, don't enable two-factor authentication unless you've done it before and you know how to use Google Authenticator. If you do, then it's okay. Okay, so then once you've registered, we will have to approve your account and you'll get an email confirming that your account has been approved. Then you can log in. So when you log in, you won't see the same screen as me because this will all be empty. I have 36 projects. You'll have 0 projects. So what you'll be able to do is to create projects. There's a limit on the number of projects you can create. I think you can find it in here in account down at the bottom, or no, here it is here. I have 25, but you'll probably only have 5. So that means in total you'll be allowed to create 5 projects. After that you'll have to mail us or contact us on Gitter to get approval for more projects. So the easiest way to get started is to run a tour, and you can see we have 3 different tours. You should enable the tour tips and then pick Spark, Kafka or TensorFlow. So Spark will just create a job, a Spark job that runs and gets scheduled on the cluster as a jar. The Kafka program will create a Kafka topic and then a producer to produce to that Kafka topic written in Spark, and a consumer again written in Spark that will read from the topic. We're not going to do either of those tours. We're going to run the TensorFlow Tour. Now I've already run the TensorFlow Tour and I have the project already, so I'm not going to run it again. But if you click the TensorFlow button, it will create this project for you, which will take about 10 seconds. And after it's created, there'll be a little button saying next, and you should click that. And what next will do is bring you to this Jupyter tab here. Now you can see there's a number of these microservices available here. That triangle is just basically saying we're more than one of our name nodes is down. We have multiple name nodes, so that's not really a big deal for us. But the microservices we have are Jupyter, Zeppelin, which is a different notebook. We're not going to run Zeppelin today. We have some jobs you can run. The datasets browser. And the datasets we can see here are, there's a number of Jupyter notebooks, and they come, when you run the tour, these get populated by all of these notebooks. Then we have logs, where the output of our TensorFlow program will be written. Notebooks are for Zeppelin. We're not going to use them. Resources you typically would use to upload jars, programs that you're going to run, Python programs. And then test job was created by the tour, and this will contain the data sets that we use in the application that we run. So we can see here that we're going to look at mnist today. It's actually fashion mnist. We'll have a look at it. There's some other ones like CFAR10, Inception, and a census dataset. And the mnist dataset, it's fashion mnist. It's split up into some training data and some validation data. So the training data is 46 megabytes of TF records, which is the native TensorFlow format. It's protocol buffers, TF records. That's what we typically use when we want to have very clean training data for TensorFlow. And this is the data we're going to use to train our model with. So I'm going to go back to Jupyter, and I'm going to now start Jupyter. And if we get rid of this button, you can this will just create a default configuration for you. In this case, we want to actually ask for GPUs. We can see in the bottom left-hand corner that there's 13 available GPUs. So I'm going to look for I'm going to run 6 GPUs. Each executor will get 1 GPU. So you can read some help if you want. The number of GPU allocated for each Spark executor. So in typical TensorFlow, you only have a single Python program you're running. In this case, we're going to run the Python program inside a Spark, a PySpark application. And that will enable us to run 6 different TensorFlow applications in parallel inside what we call a Spark executor. Now we're going to run, in parallel, we're going to run 6. And we're going to have 1 GPU per executor. We can have 4 gigabytes per executor, that's fine. And the application master in Spark, which we don't really do anything in, we'll leave that at 1024. This particular figure down here, I don't think we even need it. That's what I had earlier, so we can just remove that. So when you click on Start Jupyter, you may get a little notice here in your browser saying it's trying to open a new pop-up. You should either allow it this time, or you can click this Jupyter tab button to open the new tab that will get launched for Jupyter. Now these are all the notebooks that we have. We have not enabled the Python kernel for hops.site here, but if you do your own installation of Hopsworks, you will get the Python kernel and these will work. So these don't work on hops.site. We then have distributed training of TensorFlow with TensorFlow and Spark and Horovod. I'm not going to go through them now. I'm just going to go through the TensorFlow examples, and we'll look at one in particular, Fashion mnist. The other two that you'll see here is the Keras example, multiple GPUs, and then CFAR10 you can run yourself. So CFAR10 is a pretty good one to get started. It's a significant model to train. Now I'm just going to start this running before I do anything else. I'm going to click Run All to run the notebook, and then we can go up and have a quick look at what is covered here. So here's some background on TensorFlow, a little bit about how we're going to run this. We're using the estimator APIs, the dataset APIs, and what we can see here is that there are a few different library functions that Hops provides to make it easier to program with TensorFlow. So we have something called TensorBoard, and this will basically say that the output of our TensorBoard logging will go to a particular directory in my project, the TensorBoard logdir. And we can also find out the path to my project by just calling hdfs.projectPath. Because remember, there are lots of different projects running in the cluster. We need to know the path to my particular project when we're reading in the input data. And that's where we do it here. You can see it says here's the path to my project, and this was the subpath inside my project. You can put the whole path in here if you like. You could go back like this, go to your data set, go to the test job, go to the data, go to mnist training, and then click here and then here, and now we would have the whole path in our clipboard and paste it, but we won't. Now you can see down here that 6 GPUs were allocated, so that means it's running. If I go back to Jupyter tab up here, a new set of buttons have appeared. One to open a new Jupyter tab, we don't care about that, but we want to look at this one. This is the Spark UI, the user interface to our application that just started running. So this is a Spark application. There should be 6 executors running, and we can see down here that we have 6 executors plus the driver. Each one of those has a different GPU, and each one should have started a different tensor board. And we can see that there's 6 different tensor boards, one for each of the parallel experiments. So I'm just going to open up the first one here, and we can open it in a new window when it loads up. You can see it's training away, and it goes pretty quick because if you train Fashion mnist on a GPU, it'll take maybe 2 minutes compared to 30 minutes on a CPU. Okay, we can see the accuracy is about 85%, and this particular experiment had a learning rate of 0.001 and a dropout rate of 0.045. And you can pick a different, when they've finished running this particular menu, drop-down list will disappear. So when the TensorFlow application finishes, the tensor board for that application will also finish. But we can see that when all the applications are finished, we'll still be able to read all the TensorFlow TensorBoard logs at the end. So this one has a different learning rate, slightly higher learning rate, and the same dropout rate, and the accuracy is similar enough. And you can do this for all of the different executors. We can look at another one here, and we can see that okay, it has a different dropout rate and a lower learning rate, and the accuracy is lower. Okay, and that makes sense. If you have a lower learning rate, it'll take longer for it to converge. Now, if we go back to our notebook, what we can see is this is the actual TensorFlow code. It's inside something called a wrapper function, and this is where you put normal Python TensorFlow code in here with our helper utilities that we use to read up the data and to write to TensorBoard to a path that TensorBoard will use. So if you wanted to use additional hyperparameters, you could just add new parameters in here. So if we wanted a batch size, for example, we could write that in here, batch size. Oops, so batch size, whatever. And what we'll see then, if we just skip over this is standard code for Fashion mnist, and it's using the estimator API and the experiment API. You can see that these are the hyperparameters that we're trying out, the learning rate and dropout rates, and we pass them. We set them up by putting them in a dict. So if I wanted to add a batch size, I'd add a new entry batch, and then an array of the values that I was interested in experimenting with. So with this dict object, the args dict grid, we call it, we can now launch the parallel experiments, and that's what we use this TF launcher for. So TF launcher says I'm going to run the Spark job. This is the wrapper function we saw earlier, and for every entry in the in this table here, so every combination of hyperparameters, we're going to run a separate executor, Spark executor. And it says here that you can find your logs in here. So we can go back just to check where the logs are to make sure that's correct. Data sets logs. We can see in here we have TensorFlow, and here are all our logs that have been written for this application. And oops. So you can read some of the files if they're text-based. You can preview. This is telling me where the tensor board is running for that particular application, and here's the actual logs. So I can see logs, for example, for different learning rates, and we can have a look at them. And you can see it says it's finished running. Now, if we go back to our this is our notebook, we can see that it appears that everything is finished. We can just check to make sure. And what will happen is we'll get down to this line. Now, this is the line I told you earlier, is where we can visualize the logs that were written during the experiment that we ran. So if we go back here, we can close that particular TensorBoard window and go back to Jupyter. We can see that, oh look, the UI has disappeared. Oh, it's appeared again. This is going to be a single TensorBoard here. So this is that particular line. When we ran this particular line here, it's starting a new Spark application to visualize all of the results of our different parallel experiments. Now we can see a lot of lines on the TensorBoard as it's loading. And if we open it in a new window, just to see it a bit more clearly, we can see here that all of the learning rates of the 6 different experiments are, we'll find them in here. And then if we want to, we can zoom in. We'll just pick this one here. This is our accuracy, and we can see, oh, well, this one here looks to be the best. The blue one's not so good, so we can, click away some of those. And that purple one wasn't so good. And then you can find out the ones that were quite good and say, well, these look like good learning rates, the ones that are left. And if you wanted to then train this on a larger data set over a longer period of time, you would pick these hyperparameters and then run distributed training to train a better model. So that's the end of the demo for Fashion mnist. And if you want to move on from here, as I said, you can do distributed training with TensorFlow and Spark or Horovod. Or I would start with CFAR 10 to go to the next stage. Thanks.